Hi guys, so let us continue our discussion for case number 2. So we have here letters G to K to be solved for case number 2. So we already started last time and we solved letters A to F as well as case number 1, sample problem number 1, right? So in this session, I will be continuing the discussion for letters G to K just to complete the case number 2, sample problem number 3. And after that one, I will also be discussing case number 3, sample problem number 5, just to give you an idea of how we can solve case number 3 kind of projectile motion. So starting with letter G, so just to recall our problem for case number 2, we actually have a given of 100 meters per second for the initial velocity of our particle or the projectile, and it was launched with an angle of 37 degrees. So as you can see from the illustration, this is how it would looks like. So you have that object. It was projected with a 37 degree given by the angle, and then it experiences this kind of trajectory. So it created a parabola afterwards. And then after that, we have an initial velocity of 100 meters per second, and we were able to solve the following quantities in here initially from letters A to F. And after that, we are now to solve for letters G to K. So starting for letter G, that is the time needed to reach the highest point. So we would like to get that time it would take that projectile actually to reach the maximum height. Now, as we mentioned last time, there are two ways in which you can solve for the time. Since the time it would take this projectile to reach the maximum height is the time also that it would take the object to this is also equal for the time in terms of the vertical dimension and then the time for the horizontal dimension. If we're going to go back in here on our illustration, let's just say this is the case. This is your projectile, the one in the middle, and then of course, these are the components of that projectile, the vertical and then the horizontal. Now, if you want to get the total time it would take this projectile to reach the ground, the middle part, the trajectory itself, there are two ways in which we can solve for that time. The first way is for us to solve it through the vertical dimension, through the free fall. Diba you have two dimensions for projectile, and they have two sets of equations independently from each other. So if we can solve it using the vertical dimension through free fall, then by all means, let's do that if it is possible. And if not, we have another option, which is in terms of the vertical dimension, because the time here for the vertical dimension is just equal. It's just the same for the time here on the vertical dimension or the vertical component of our projectile. So since that is the case, whichever of this dimension you are going to use, it is just fine, because whatever value you will get in here, that's also the value of the time here on the projectile itself, on the trajectory itself. So that is also the case for letter G, wherein we are asked to solve for the time needed of this particle to reach the highest point. So again, our option is to solve it using the vertical or the horizontal dimension. So since for the for the horizontal dimension, diba, we only have one equation to use under the under the horizontal dimension, and that is the simple formula of velocity equals to delta x over time. Now, if we're going to consider that the horizontal dimension to solve for the time, we actually don't know the value yet for the delta x. What do I mean by that? The delta x, or the distance from the starting point until the half way of the trajectory, is not yet given, because this is the equivalent distance with respect to the highest point. So you can actually solve for the time if we are given the delta x and then the vx. Although we are already given the velocity along the x-axis, because that is just the same for all of the points of our projectile in here. We already solved for the x component of the velocity of our projectile, letter A. we can use that actually to solve for the time in terms of the horizontal dimension. But the thing is, we don't know yet the value of the delta x for the halfway of that length of our delta x. So the last option that we can use to solve for the total time, I mean for the time it would take this projectile to reach the highest point, is through the vertical dimension. So we will be doing free fall. Okay, so you always have to remember that whenever we are going to use the vertical dimension, it's as if we are doing free fall. Okay, we will be going back to that idea of free fall. Now, to solve for the time at the maximum height, since we will be doing free fall, we would have to consider whether the object is moving upward or downward. And as you can see, the object is initially from the ground, and then we would be measuring the time it would take to reach the maximum height. So that would be an upward kind of movement for free fall. So that's the first thing to consider. So we considered it as an upward movement in terms with respect to the vertical dimension. Now, the second thing to look for is the start of the analysis and then the end of our analysis. So in which situation our analysis is confined. So as you can see from the illustration, the start of our analysis would be, of course, from the start in which that object was thrown from that certain angle. So it would be the VI of our velocity. I mean of our velocity in the y dimension. So the VIY that we solved from letter B a while ago, which is the y component of our initial velocity, would also be the VIY in here. That would be our initial velocity in here since we are only considering the vertical dimension. So that's your VIY. Now, for the other given, since the end of our analysis would be that highest point, and we know that the highest point of the projectile is that point wherein its velocity would be equal to 0 because it would momentarily stop, right, at that highest point. So your VFY in this case would be equal to 0. That's the second given. And then the third given is our automatic given, which is the value of negative 9.8 meters per second for the acceleration. Okay? Now, identifying the unknown, that is the time, and then given all the following quantities in here, including the unknown, we can actually conclude that the missing quantity is the delta y. So with that, delta y with respect to the highest point. Kasi you would have to consider all the quantities on that point only. If you are measuring the time at the highest point, all the quantities that you should use are also within that highest point. So just like what we did last time, we analyzed the different quantities of our projectile at time is equal to 1 second. So we considered the velocity, the delta x, the delta y, and all the other quantities at that point. So in this case, for letter G, what we are looking for is the time at y is equal to y max. The time it would take that object to reach the maximum height. So all the quantities that should be involved here are also found on the maximum height of our object. So since we don't know yet the delta y, that would be our missing quantity in this case. Okay, so given that it is our missing quantity, we can use the first equation to solve for the time, right? So with that, our first equation is the VFY is equals to VIY plus GT. And we can actually simplify this one by canceling out the VFY first because it is already 0. And then you proceed to deriving the working equation for time. So to do that, we're just going to to transpose the term of VIY to the other side, making it negative and then canceling out the G to isolate the time, making our working equation negative Vy divided by G. Okay, and then furthermore, substituting our values, we would have here negative 60.18 meters per second divided by negative 9.8 meters per second squared. So that would give us the time it would take that object to reach the maximum height, which is 6.14 seconds. Okay, now moving on with the next question, which is letter H. The problem is asking us to solve for the particle's velocity at the highest point. So you have to remember, letter H is asking us to solve for the particles or the projectile's velocity. And we know that the velocity of a projectile is composed of two things. They are its x component and its y component. So in order for us to get the particle's velocity at the highest point, we should also identify first the x and y component of our particle's velocity at the highest point. So what are those? So the first thing that we can actually name is its x component at the maximum point, and that would be 79.86 meters per second. So where did I get that 79.86 meters per second? That is the value that we solve actually initially from letter A, right? That's the x component of our initial velocity. Now, as we mentioned repeatedly, the x component of the projectile at every point would be the same. So if you are looking for the projectile's velocity at the initial point, at the highest point, final point, the x component of all those projectiles velocity would be the same to each other because the x component of our projectile's velocity is never changing. The acceleration is equal to 0, making our velocity constant along the way within the x-axis, because on the y-axis, of course, we noted that it is changing over time. So that would be the value for the x component of our velocity at the maximum height. So the same value of the x component, just like the initial x component of our initial velocity. So it would still be 79.86. Now, to get its second component, which is the y component of our velocity at the maximum height, it would give us 0. Why? Because we know that at the maximum height, for the vertical dimension, treating it as a free fall, the velocity of our object at the maximum height would be equal to 0 because it would momentarily stop there with respect to y-axis. Okay? So, yan. So, those are the two components of our velocity at the maximum height. So, solving for them, it would give us solving for the Pythagorean theorem of these two, substituting it to the formula of Pythagorean theorem to get the velocity at the maximum height. It would give us is still 79.86 meters per second. Because anyway, it would just cancel out the v max y. I mean, its y component with respect to the y component of our velocity at the maximum height, since it is 0, you would only be retained with the square root of 79.86 squared. So the square root and then the squared would cancel out. You would have now your answer, which is 79.86. So at maximum height, in case 2, the value of the projectile's velocity at the maximum height is just equal to its x component because the velocity at that has the y component of our velocity at the highest point is 0, since it would momentarily stop with respect to the y-axis. Now, moving on with letter I, we are expected to solve now for the maximum height. So a while ago, for letter G, we solved for the time it would take to reach the maximum height. For letter H, we solved for the velocity of the projectile at the maximum height. Now, for letter I, we will be solving for the height in terms of the vertical axis or the maximum height that that the object reached at that point. So what is the value of that height when it reached the maximum height? So delta y max is what we are looking for letter I. So since as you can see in here, we are looking for delta y max, and trimming down the right equation to be used from the 3 sets of equations that we have, you can already cancel out. You can already disregard the third set of our equation, which are the special equations that we have, because this problem is only pertaining. Actually, you can use the third set of equations, specifically the equation for the y max. This one. You can use this equation in letter H is equal to vi squared sine squared theta divided by 2g. You can use this equation because that problem that we are solving is a case 2 problem. These are applicable for case 2. And then we are solving for the maximum height. So you can actually use this one as one of your options to solve for the maximum height of the particle or the projectile. Pero kasi the problem with this one is the idea that you would be encoding this or inputting this on your calculator. So if you're not familiar that the sine squared theta should be encoded as sine theta, all of them raised to 2, it would be hard for you to use this one because if you're going to input sine squared theta on your calculator, it would give you a syntax error result. So you would have to remember the idea that to input this on your calculator, it should be parenthesis sine theta, parenthesis, close parenthesis, raised to 2. All of them enclosed to raised to 2. So, kasi that's the idea of sine squared theta. That's a half angle. Okay, you can use this one as one of your option, and the second option is for you to use its dimension aspect, wherein we will be focusing on the free fall aspect of it, since this is delta y. So in this case, in this solution, we use the idea of the dimension, wherein the start of our analysis is that point wherein it was thrown, and then the end of the analysis would be that point wherein it reaches the highest point, because that is what the problem is asking us to solve for, the maximum height. From this point until this point, you look at the y dimension of that. Dito ka lang, y dimension. The start and then the end of the analysis is the highest point. So that is where we could get our final velocity. So writing all of the givens in here, applicable givens that are present at the maximum height, and then the start of our analysis is the start wherein it was thrown, and then the end of our analysis is the part wherein it was thrown. All of the given within that scenario, you will have to write all of those. Okay, so the first thing that we write here is the final velocity, which is equal to 0, because the end of our analysis is the maximum height, and we know that at the maximum height, the velocity of the velocity of an object with respect to the vertical axis is 0. And then the VIY, as we just like how we computed it a while ago, I mean from letter A, it would give us the value of 60.18 meters per second. And just to mention, guys, no, I was not able to mention, we consider that this object is an upward kind of projectile. And then also we identified the start of its analysis, which is the point wherein it was thrown. And then the end of the analysis is that point wherein it reaches the maximum height. So that is where you're going to focus your analysis, the end and start of your analysis. And with that, yun na nga, we were able to identify the final velocity because the end of our analysis is at the highest point. And then initial velocity is 60.18 meters per second, just like how we computed it initially, and then the automatic given of negative 9.8 meters per second squared. Now, we also know that the maximum, the time it would take for this object to reach the maximum point as we solve it from letter G is 6.14 seconds. So you could also write that one as you're given in here, because that is within your analysis. That is within your analysis, so we will be including the T max, or the time at the maximum point, which is 6.14 seconds, which is 6.14 seconds to be included in our given. So given all those four things and then the only missing quantity is the delta y max, we can actually use all of the equation except for equation number 3. Except for equation, actually, dapat ito ay equation number 1. Sorry. So that should be equation number 1, ha? So, because on equation number 1, delta y is not present on that equation. And the rest of the equation, you can use them because delta y is present in there and the rest of the quantities are also given. But in this case, we use equation number 5. You can also use the other equation. You can recheck if you will be getting the same answer, and you should be getting the same answer. Okay, so using equation number 5, we have here that equation we wrote here, and then we canceled out the VF, the final velocity, since it is 0, and then derived the working equation for delta y. So transpose the VI to the other side, and then cancel out 2g to isolate delta y, giving us the working equation of negative VI squared divided by 2g. So substituting the values here, we have the following, and then computing for its value, you will have 184.78 meters per second. So that is the value of the height. Ay, sorry. It should be meters lang, ha? Sorry, that's another thing that you would have to correct. Sorry. It should be meters only since this is since we are looking for the height. Okay, not velocity. So kindly correct this one on your tawag nito, on your reference if you're going to print this out or if you downloaded it. You just kindly take note that it should be in meters. And another thing is in here, you can use all of the equation except number 1. Now, let's have letter J. Let's answer letter J. So for the question in letter J, we are asked to solve for the total time that the projectile is traveling in the air. So actually, you have two options to solve for this. The first one is through the special equation wherein you can just simply input, where's that? Here. You can just simply input the value of the projectile's initial velocity, which is 100 meters, right? And then the sine theta, which is 37 divided by g, the negative 9.8. So you can already solve for the total time of flight using this equation. So that's your first option. And then the second option is for you to use the symmetry or use the dimension, vertical dimension, to solve for the total time because we already know the time it would take this object to reach the maximum height, the half of its travel. So because of time symmetry, we know that the time it would take this object to reach the maximum height would also be the time it would take to reach the same point downward. So all you have to do is to multiply it by 2 and voila, you would have your time, total time, which is 12.28 seconds. Okay? So, yan. It should be, kasi we are actually looking for the Tmax and horizontal range in here. And di ba sabi ko sa inyo, the time for the horizontal is also the same for the time in the projectile, total time in the projectile, and also total time for the vertical. So, even if we solve it in terms of the vertical, there's no problem with that because they are just equal to each other. Okay? Yan. And lastly, case number 2, sample problem number 3 is asking us to solve for the range or the total distance in terms of the horizontal dimension or our delta x max. So again, you have two options to solve for this. Actually, I did just to show you. The first option is for us to use this special equation, which is r is equal to vi squared sine 2 theta divided by g. Okay. Since we already have the value for the initial velocity of the projectile, that's 100 meters per second, as well as the angle, that's 37 degree, and also the g. So you can just simply substitute everything. You would have your range, value of the range, which is 980.88. So that is your first option. You can use the special equation since this is case number 2. Now, the second option is for us to use the dimension aspect of our projectile. In this case, since we are looking for the delta x, we can just simply use the formula, the only formula for the horizontal dimension, which is the VI x is equals to delta x divided by t. So you isolate delta x, you derive it from the VIx equals to delta x divided by t, you would have your working equation to be equal to Vix times time. So substituting the value, it would give us 980.68. And if you're going to compare, guys, using the formula for the dimension and then the special formula, it would have a very, small discrepancy in terms of the answer. And that's okay because it's just because of the difference due to the rounding off as we solve it along the way. Because if you're going to be consistent in solving it, especially for the dimension part in here, the answers that you used here are all rounded off. So that could be one of the factors why they are not exactly the same to each other. Pero if we're going to be consistent, we are not going to round off our answers for the VIX and then the time, it would absolutely give us the same answer. Pero there's no problem with that because the whole number answer is just the same to each other. It's a minimal discrepancy because of the rounding off. Okay, so that's for case number 2, sample problem number 4. Now, we will be moving on to case number 3, sample problem number 5. So, for case number 3, sample problem number 5, as we mentioned last time, this kind of problem would give you the idea, or it would visualize the idea that your object was thrown from a certain height at a given angle, just like what is shown here on the illustration. So you have that object, and initially it was thrown from this certain height of a building. And then, aside from it being thrown on that height, it also has a value for its angle. Unlike for case number 1, wherein it was also thrown from a certain height, but the difference is that it was thrown horizontally. Diba? You would have your conclusion that for case number 1, your initial velocity of the projectile would be equal to its x component, and then the VIY in that case would be 0 because it's completely lying on the x-axis. It was thrown on the horizontal dimension, and then it was just affected by the gravity. That's why you have your parabola. In this case, you will have your x and y component for the initial velocity because it was thrown with a certain angle. So your VIY in this case would not be 0. Same thing with your VIX. You would have a certain value for that. So the thing that made this complicated is because it is the combination of case number 2 and then another case of projectile at this point. So diba you have your 3 dots in there. So the first dot and then the third dot would actually give us, you can use the analysis of case number 2 on those points, but on from the third dot until the last dot in here, the last part of the trajectory, it would not we cannot use case number 2 in that case. So it would be another kind of analysis for us. So for case number 3 kasi, it would be a 2 sets, parang you would be able to analyze it by treating it into 2 trajectories. The first trajectory would be something like case number 2. From the first dot until the third dot in here, you can treat that part of the trajectory as case number 2. And then the last part of your trajectory, which is the third dot until the last one, would be another set of trajectory. So that is the easiest way you can view it para mas madalian kang ma-solve. Okay, so you treat it into those 2 trajectories. Okay, so in case number 3, we have here the specific given or situation wherein a ball is released from the top of a building of a height equal to 10 meters, and then and the initial velocity is VI. 10 is 10 meters per second. So again, we will be using the acceleration due to gravity. And then aside from that, it is also given that the angle of projection is 30 degree. So we have to find only two things. The first one is the time needed by the ball to reach the ground, and then letter B, the horizontal distance reached by the ground. So how do we solve letter A, the time needed by the ball to reach the ground? So you have you only have two options for that, diba? You cannot use the special formulas for this because this is not case 2. The geometry aspect, you can also not use that because you don't have time for that one. Geometry aspect, diba? It's just the VI and then the angle and also your two components. We can only rely on the dimension aspect to solve for the time. And looking into the dimension aspect equations, you have uh, two parts in there. You have the horizontal and then the vertical. So either way, you solve the total time, it's okay. The only problem is which of these two dimension would make it possible for you to solve for the time. Okay? So by inspection kasi, since for horizontal dimension, the only quantity that we need in order to solve for the time, if we're going to use the horizontal, is the delta x, which is actually not yet given because it is also being asked for letter B. And then the V, although we can get the VIX because you can solve the VIX in here by you have the VI and then the theta, so you can just solve it by VI cosine theta. Although you can solve for that, hindi kasi it would not help us still to solve for the time because we don't have the delta x yet. So the only option that we can use to solve for the time here is to rely on the vertical dimension of our projectile. So that would be on its free fall aspect. So to solve for the time on the free fall aspect, as I mentioned earlier, we will have to treat this projectile into two, parang you would have to divide it into two. The first part of the trajectory would be treated into case number 2. From the first dot until the third dot, as you can see, it would give us a parabola and same level silang dalawa. So, we can use the concept of case number 2 for the first part of the trajectory of this of case number 3. So, in that case, for us to solve the total time, we can actually use the symmetry, the idea of the symmetry, since we are only focusing, I divided it into 2. So the first case, the first part of the trajectory would be treated in terms of case number 2, and then the second one would be treated as another kind of trajectory of the projectile. So let's focus first on the first part of our trajectory. And that would be by treating it as a case number 2. So with that, since we would be treating it as a case number 2, to solve for the total time, we can use the idea of time symmetry. So to use the time symmetry, you can just focus on one part of this, half of this parabola. Kasi if you will be able to get the time of that half of the parabola, you can just multiply it into 2 to get the total time of that parabola, since we know that we have the concept of time symmetry. Right? So I'll just repeat. The first thing that we did in here to get the total time is we divide the trajectory of case number 3 into 2. The first part of our trajectory is that point from the start until the same level, making it a case 2 kind of projectile. So our analysis in there would be just the same as we did during the case 2 problem. And then after we got the total time in there, we would be now solving for the time for the remaining parts of the trajectory, which would be the second part of our analysis. But for now, we will be focusing first on the first part of your trajectory, which would be treated as a case number 2, since it would give us a parabola shape of trajectory. Okay, so to solve for the total time, we would be focusing only on the half part of this parabola to make it as our end of the analysis and then the start of our analysis. So the start of our analysis would be that this point wherein the object was thrown, and then the end of our analysis would be the highest point. Okay? So you have to think that we are solving for the free fall in this case because we are using the vertical dimension. This is a free fall kind of case. That's why we have to only focus on just half of the part and then you just multiply it into 2 later because of the time symmetry. So let's just focus on the half part of this parabola, just the upward case of the free fall. So our start of the analysis is the starting point. And with that, I need to find for the y component of the initial velocity because we are only given the velocity of the initial velocity of the projectile itself and we cannot use that to solve for the time kasi this is only for the vertical dimension. And that the VI that is given to us is the actual value of the projectile. So we need to extract first the y component from that initial velocity. So to do that, we will be using the geometry concept since we are given the VI as well as the angle. So we solved in here the VIY, and then that would give us 10 meters per second times sine 30. And the answer is 5 meters per second. So that is our VIY. That is the start of our analysis. And then for the end of our analysis, which is the highest point of our projectile, it would give us a VFY of 0, which is equal to 0 because at the highest point, the object would momentarily stop with respect to the vertical axis, making our final velocity equal to 0. And aside from those two given, the automatic given that we have for free fall is negative 9.8 meters per second squared, and then the unknown value is the time. Okay, so since we have the following 4 out of 5 kinematic equations in here, and then the missing quantity is delta y, we can use equation number 1 to solve for the time. So using equation number 1, we can just cancel out the VFY and then simplify it, derive the working equation. It would give us negative VIY divided by G. Substituting the value, you would have negative 5 divided by negative 9.8 meters per second squared, giving us 0.51 seconds for the first half of that parabola. So t is equal to 0.51 seconds from start to the top of the parabola. The first part, you only have to look at this first part of the trajectory wherein we treated it as case number 2. So half of that parabola is 0.51 second, and because of the time symmetry, from the top to downward, same level, it would also give us 0.51 seconds. So overall, the time of the object dito sa first part of our trajectory would be 1.02 seconds. Okay, so we are not yet done because that is not yet the total time of the travel of our projectile. It's just the first part. The first part of the travel of our projectile took that object 1.02 seconds. But how about on the last part of its travel, this second part of its trajectory? How do we solve for that? So since we will be solving for the last part of our trajectory, you can use the horizontal and then the vertical aspect, but it's very much impossible as of now to use the horizontal dimension because we do not have the delta x for those for that specific point. So the only thing that we can use is the vertical dimension. So with that, let us analyze it through free fall since vertical lang gagamitin natin. So first things first, you determine whether it is an upward direction movement or downward. In this case, we would be analyzing it from this point until that moment before it reaches the ground. So it would be a downward kind of free fall. So since this is a downward kind of free fall, all of the given should be negative and the only positive value in here should be the time. So, yun. Later on, the value that we should be getting is just a positive time. Now, kindly take note also, I was not just able to indicate negative here on the given, but eventually naman when I substituted the value, it was negative. So, yeah, if ever you might be confused, there should be a negative in there. I was consistent naman when I substituted it in the value. So, everything is still intact. I just forgot to write the negative in there sa given natin. So, how did I get VIY as negative 5 meters per second? Where did I get that value? So, the VIY actually came from, um, it actually came from our initial velocity. So, we are initially given a while ago of a velocity, initial velocity equal to, diba, our initial velocity for the projectile is equal to 10 meters per second. So, that's 10 meters per second. So, where is that point? That is in this starting point. In here. Yan siya. Dito siya. And this part. This is your, wait. This is your, sorry. Basta that is where your initial velocity is located. On the initial point in there. Starting point. Okay, this is where your initial velocity is lying in here. Now, according to the velocity symmetry, the velocity of an object, we are focusing on symmetries because we are solving it in terms of free fall, right? So we can use the time symmetry and then the velocity symmetry. So according to the velocity symmetry, that the velocity of an object at one point when it goes upward should also be the same at that same point when it goes downward at the same level. So the velocity in here of this projectile should also be the same with the velocity in at this point kasi they are just on the same level. That is according to the velocity symmetry. And with that, if I want to get, because we are analyzing all the givens in at this point with respect to the y-axis. So if I want to get all the given values in here with respect to the y-axis, I need to get the VIY at this point. Why did we have why did we wrote VIY at this point in here? Diba we already have our VIY at this point? So why is it that here VIY we will still have VIY in here? That's because at this specific point we are making our analysis. The start of our analysis would start now at this point. That's why our initial velocity would be located at this point now. So your VIY would be coming from this point because this is the start of our analysis. Now, how will you get that VIY? That VIY should come from the VI, the value of the projectile at this point, and then its angle. So that angle is your theta. Now, according to the velocity symmetry and then case 2, actually on case 2, another thing that I was not able to mention to you, the angle, thus the angle of projection at this point is actually also equal to the angle at this point, same level. So that the value of the angle in there, which was given 30 degree in here, is also the angle at this point, 30 degree. So we can use the formula VIY is equals to VI cosine theta to solve for the VIY component in here to get the initial velocity at this start of our analysis. So with that, we can just simply solve for the VI cosine theta, which would give us 10 meters per second cosine. Theta is 30 degrees. So it would give you the value of what we have here, which is the 5 meters per second. We will just have to indicate that it is negative because the object is moving downward. So that's the first given, your VIY, negative 5 meters per second. Again, we were able to get that by using the idea of velocity symmetry and that and also the idea that the angle of projection is also equal to the angle at the same level at the end. So that's why it was possible for us to solve for the VIY through VI sine theta. Wait, was I able to use sine theta? Sorry, yeah, it should be sine theta. That's because we are solving for the y component. I cannot edit it out na eh. Basta that is sine theta because this is y component. So it should be sine theta. It would give you 5 meters per second. Okay, negative 5 meters per second because it is downward. Now, aside from that, you would have to focus the start of our analysis now is at this point, and then the end of our analysis is that moment before it reaches the ground. So that would be the points wherein you will get all your given for us to solve the remaining time on that part of the trajectory. So the start of our analysis gave us the initial velocity, which is negative 5 meters per second. And then the g is negative 9.8 meters per second squared. Aside from that, we also have the value for the height at that level, negative 10 meters. Where did I get negative 10? It was also actually given in the problem because it mentioned that the height of the building is 10 meters. So you can use that value because it is just the same level as the distance that the object would travel with respect to the vertical dimension. So we could just treat that height as our delta y on this specific point sa second part ng ating trajectory. And since this is a downward kind of free fall, we would be indicating it to be negative 10 meters. Okay, so much for the given. You have the following three given, and then we also know that the unknown value in here is the time. So out of the five kinematic quantities, the remaining missing quantity is the final velocity. So with that, we need to use the third equation, which is delta y is equals to VIYT plus 1/2 GT squared. Okay, now, so substituting all the value, actually in here, I did not derive the working equation because as you can see, it would not be possible for us to combine t squared and then t all together because they are of different degree. So as you can see, since we have two same variables of different degree, one is raised to one of them is raised to 1 and then the second one is raised to 2. So you could actually rearrange this into quadratic equation and then get the ABC to solve it through quadratic formula for us to solve the time. So that's the only possible way for us to solve for the time, through quadratic equation. So let's substitute everything first and then later on rearrange it into quadratic equation in the form of ax squared plus bx plus c is equal to 0. Okay, so substituting all the values in here, you would have negative 10 meters for the delta y equal to VIY is equal to negative 5 meters per second. And then the time is just time since we are looking for that plus 1/2 times negative 9.8 meters per second squared. And then of course your t squared. Now, to rearrange this or to pattern it into a quadratic equation, we would not be including the units anymore. At this point only, whenever you are only using quadratic equation, para kasi hindi na siya mahirap i-analyze. Okay, and then makuha nyo rin kaagad yung pattern ni ax squared plus bx plus c. So, which one would be our ax squared in this case? That term wherein you have squared variable, and that is the 1/2 negative 9.8 meters per second. So if you're going to simplify that, it would give us negative 4.9 t squared. And then, which one would become our bx? That quantity which contain the same variable which is raised to 1. And that is the negative 5 meters per second squared. So simplifying, you can just write negative 5t plus 10. So where did I get that plus 10? We just transpose it to the other side so that all of them should be found on one side only. So it would become plus 10. And we would be equating it into 0. So that equation now would be patterned to the quadratic equation, which would give us negative 4.9 t squared minus 5t plus 10 is equal to 0. And with that, you can already identify which one's the A, B, and C. Why do we need that? Because you need to find which one is A, B, and C in order to substitute it to quadratic formula. So which one is our A? A in this case is negative 4.9, the B is negative 5, C is positive 10. So those values should be used here on our quadratic formula. Okay? Yeah. So to solve for the quadratic formula, of course, let us write the quadratic formula itself, which is negative b plus minus square root of b squared minus 4ac divided by 2a. And then you just substitute all of the values in there. Ang lahat ng b, ilagay mo, they are negative 5. The a is negative 4.9, c is 10. So solving for everything, all of that, you solve first the quantities inside the square root. So it would give us 221. And then you separate it into 2 because one should be solved in terms of addition. The other one should be solved in terms of subtraction. So for quadratic equation, you would actually have two answers for this. But of course, since we are looking for the value of time, you will be getting that value for that time, which is positive. And that is 1.01. Okay, kasi for the first one, 5 plus square root of 221 divided by negative 9.8, it would give us negative 2.03. We don't have any negative value for time. That's not possible reality-wise. We cannot use that. And then the only answer that would make sense in here is the answer from 5 minus square root of 221 divided by negative 9.8, which is positive 1.01. So, how will you get now the overall time that this object took in order for it to travel from the starting point until that point wherein it reaches the ground? So, yung first part ng ating trajectory, which is the parabola, gave us 0.88 times 2 or 1.02 for the first part of its trajectory. Now, on the second aspect naman of its trajectory, we were able to get that it is 1.01. So, adding the two of them together to get the total time would give us 2.03 seconds. Okay, so that's for letter A. Now, finally, how do we solve for the delta x max or its range in terms of the horizontal dimension? So you cannot use the special formula for this because this is not a case 2 kind of problem. So you would only be relying on the on the horizontal dimension. So medyo madali na lang naman ito because on the horizontal dimension, you only have one equation to be used. And that is the VI is equals to delta x times time. So mind you guys, we are actually getting this entire x part in here sa baba. What is the length of that x distance, delta x distance from the start until to the finish? So all your variables or all the quantities that you will be using should be within that analysis. So ang start natin, the velocity is just constant along the way, and you can get that by solving it through VI cosine theta because we are given the VI, which is 10, and then cosine 30. 30 is the angle given a while ago, and it would give us 8.66 meters per second. This is the velocity of your object at every point within that horizontal dimension. So that actually gave us the conclusion that we will be only using the simple equation for velocity, which is just delta x over time. So isolating delta x out of that general equation, we would get Vix times time. And what are the values that we should be substituting in here? The Vix is from the x component of the projectile's initial velocity, because it doesn't matter in which part of the projectile you will be getting the x component because they are just the same at every point. So yeah, it would give us 8.66, and then the time is that we need to use the total time in here because we are looking for the total distance in terms of the x-axis. That's why we use 2.03 as our time. So it would give us 17.58 meters for the delta x. Okay, so the actually case number 3 is, as I mentioned, it's the more complicated case out of the 3 cases. And for your exam naman, you can just focus on quiz 1 and 2 since dun mostly magre-rely ang mga questions ng inyong exam as well as the quizzes. For case number 3 kasi, we just gave this to you so that you will have an idea, you'll be familiar with this kind of cases ng ating projectile. Yeah, so that's it for the rest of the discussion for the projectile motion. I hope you were able to get it. If not, repeatedly watch the video, or you can use other references, YouTube. Please, yun lang, parang please exert an effort talaga to be able to understand and practice solving the problems. That's the only way, I guess, based from my experiences, that's the only way you can practice, master your skills, and understand the concepts. Okay, so thank you very much, guys. That's all for this session.